Hello and welcome. In this video, we're going to look at one of the last graphs that we need to look at for Module 2, where we are organizing and visualizing data. This type of graph is going to be called a frequency polygon. A frequency polygon displays the data as a line graph that connects the points at the class marks. A line graph. Sorry. So if you recall from the last videos, we talked about class marks. The class marks are the same thing as the class midpoints. Sorry, my stylus is not seemingly working today. There we go. The class mark is the class midpoint. And in order for our graph to make sense, we're going to have to add some additional class marks to the outside of each class boundary. So there's an example here. It says construct a frequency polygon for the following data using graphing utilities. So the data set here is the weekly study hours for a sample of 150 college freshmen at a community college. The information is given to us in classes or categories. The classes or intervals are from 1 to 5 hours, 6 to 10 hours, 11 to 15, 16 to 20, so on and so forth. Quick recap from a previous video. What is the class width for each of these classes? Is it 4, 5, 6? It is 5. Remember that the class width is always the difference between the the lower limit of 2 consecutive classes. It could also be the upper limit of 2 consecutive classes. So if we did this, we get 6 minus 1 is 5. Also, if we look at the first class here, from 1 to 5 study hours, we would have the numbers 1, 2, 3, 4, and 5. So we have 5 different numbers. Most students try to subtract 5 minus 1 and get the class width of 4, but in this case it is 5. All right, so that was a little addition to this. We're not needing to worry about the class width for this class, for this example. What we do need to do in order to construct a frequency polygon, which again uses the class marks or the class midpoints, is we need to find the class marks for each of these. So the class mark is found by taking the lower class limit and the upper class limit and adding them together and dividing by 2. So in this case, we'll do 1 plus 5 divided by 2 to find the midpoint. 6 divided by 2 would be 3, so the class mark is 3. We'll do the same thing with the next one, and then I'll jump ahead, kind of speed this up a little bit. 6 plus 10 is 16, divided by 2 is 8. And again, if we know that the class width is 5, we're just going to continue the pattern of adding 5. So 3 plus 5 is 8, plus 5 is 13. Also 11 plus 15 is 26, divided by 2 is 13. And then we'll have 18, 23, 28, and 33. I'm going to make a separate video for graphing these frequency polygons in both the TI-84 and GeoGebra, so you can look at those in the future, but we do need to know the class boundaries for the GeoGebra, so let me just explain this real quick. The class boundaries are again the midpoints between the upper class limit of one class and the lower class limit of the next class. So the number between 5 and 6, or if you think of this as like the rounded value, what would be the value that would round down into the first class or would round up to the second class? So between 5 and 6 is 5.5, so that would be the class boundaries between the first and second class. And again, between 10 and 11 would be 10.5, so those are where the class boundaries are. Now, I had mentioned earlier in this video that we need to also make sure that we add an additional class mark to the outside of each side of the graph in order to show where the graph starts and ends. So we also need to add the class boundary beyond the endpoints. So below 1 would be 0.5, and above 35 would be 35.5. Okay, so I have a few graphs here. We're going to look at them, and again, we'll spend some time in the next videos showing how to graph these in our graphing utility. In the first picture that we have here, we have the frequency polygon, where each of these class marks are shown as points. It's just kind of floating out in space. The reason why we need to add an additional class mark is we need to show what's happening before this class mark. Is there information before this class mark that is not being shown, or does it start at 0? The same thing over here. This one had a very low frequency, but the graph should go down. But who knows? If we don't show it on the actual axis, we don't know where the graph is going to continue after this. So this is the reason why we need to add an additional class mark to the outside of the graph to show that it's starting at the origins. Or the horizontal axis is another way of saying that. So here's where what our graph would look like. We have our study hours as the label of the horizontal axis. We have a label of the graph. This is the frequency polygon for study hours of freshmen at a community college. We have the frequency as the vertical axis here. We have a class mark at 3, which has a frequency of, looks like 32 from the graph. I could scroll back up to the table to confirm that. We have another class mark at 8, another class mark at 13, another class mark at 18, another class mark at 23, another class mark at 28, 33, and 38. So again, the graph starts at -2 because we need to show that the graph starts with a frequency of 0 and ends at 38 because we need to show that the graph ends with a frequency of 0. So it's showing the full graph here. It's not leaving anything to question. So this is a frequency polygon, again, a line graph with points at the class marks for the frequencies of classed or grouped data. If we now go back to our table of values here, our data set, we also have cumulative data and a cumulative frequency column. We could graph this as the cumulative frequency polygon, and a cumulative frequency polygon has a special name to it, and I'll show you that in a second. But again, just to make sure we know we're up to date about cumulative, again, this is always up to and including our data values. So up to and including these. So within the first 1 to 5 study hours, we have 29 students, so our cumulative frequency is 29. Up to and including 10 hours of study would be everyone in the first group plus everyone in the second group. So 29 plus 26 would give us our 55. If we go from 1 to 15 hours, this would be 29 plus 26 plus 36, or 55 plus 36. So again, up to and including 15 hours. So we're just going to continue to add up all of the frequencies, and we'll get a total of 150, which is great because we were told in the lead-in question here that we had 150 college student data. So for our cumulative frequency, I'm just going to scroll through the notes here. Again, I'll make another video that explains these in detail. Our cumulative frequency polygon is called an ogive. This is a soft G, sounds like a J. An ogive is a polygon that displays the data as a cumulative frequency, which is frequency from previous classes are added in successive classes until all the sample values are included. I have a picture of a cumulative frequency ogive here, which shows the maximum part of the graph here ending at 33. And again, I'm never going to make you make me one of these graphs. It's not super important that we're familiar with these. An ogive is actually one of the least important graphs of the Module 2, so I'm not going to spend too much time here. Basically, what we can look for is like the steepest portion of the graph would be the area with the largest number of students. The flattest portion of the graph would be the area that has the least number of students, and there's really not much use to an ogive beyond that. So again, frequency polygon and a cumulative frequency polygon called an ogive. Now, why do we want to visualize data? Well, we're still working in the introductory settings, introductory content of statistics, where we're looking for how we can best interpret and understand the data without having to do too much math, really. So In visualizing the data, we can get a bunch of information about the data set, about the sample or the population that we're studying, to try and figure out some information. We can see whether or not there is a skew of the graph. In this case, there is a skew to the left. We always talk about the skew as the direction to which the graph is being dragged. In this case, it's being dragged to the left or the negative side. Or we can look at graphs that have a positive skew or a right skew to them. One of the things that we're going to spend a lot of time doing this semester is looking at a symmetric distribution. A symmetric distribution does not have any skew, and there's a definition right underneath it. It says the data values with the highest frequencies are found in the middle of the data interval, and the frequencies drop off symmetrically towards the left and the right. We'll spend a large portion of time talking about symmetric distributions in the future. We also have a bimodal distribution. We haven't learned what mode is yet, but a mode is the highest frequency outcome in a data set, or a uniform distribution, which just means that the frequency is constant for every value that exists in the data set. And then there's some more information here for positively skewed and negatively skewed, which we'll get into a lot more detail of as we progress through the course. So this is the last video of Module 2. Thanks for watching all these videos, and feel free to reach out if you have any questions.